We're about to begin.
En la anterior mesa redonda hemos hablado sobre usuarios.
We have talked about road users, safe users, and now we will talk about safe vehicles. José Manuel Pedrio from the Ministry of Industry, please come up to the stage.
Bueno. Buenos días a todos.
Good morning, everyone. I will begin with a few words in Spanish, and then as a mark of respect to the other speakers, I will change to English. I'm representing the Ministry of Industry and Tourism, and I must acknowledge the effort made by Asesor and DGT in order to increase and encourage motorbike safety.
Continue the meeting. So, first of all, let me introduce to our colleagues. First of all, let me introduce to Mr. Fischer. Mr. Fischer acts as Senior Advisor to Yamaha, where he represents the company interests at Association of European Motorcycle Manufacturers at EU level in Brussels and in other various consortia such as Connected Motorcycle Consortium, Swapping Battery Motorcycle Consortium, and Car-to-Car Communication Consortium. He is actively involved in ITS development and vehicle safety issues with his combination of engineering background and journalist background. He reached the technical and marketing discipline in the motoring industry. So welcome, and please be welcome and take a seat. I don't know, whatever you want. The second colleague that I'm going to introduce is Mr. Brend. He worked for Honda Motor Europe. He's focused on regulatory and governmental affairs, shaping EU policies for cars and motorcycles in the field of cooperative, connected and automated mobility, engages with industry associations like ACEA, ACEM, and JVCE, and currently serves as chairman of the working group of ASA at ACEM, engaging in policy discussion on motorcycle safety. Welcome. Last but not the least, our colleague Adriano Palao. Adriano Palao is an automotive engineer with over 10 years of experience in the vehicle testing and validation domain. As a technical manager for ARAS and AD at EuroNCAP, he steers the working group related to active safety and is responsible for protocols development toward promoting enhanced vehicle safety. So welcome again. And finally, just two short introductions for myself. I'm Deputy General Manager in the Ministry of Industry and Tourism. I'm in charge of all the regulation and homologation of vehicles, and it's a pleasure to be with you all here. So the idea today is, as before, is 10 minutes per presentation for each speaker, and after that we have the chance to do some questions to the speakers. We are going to change a little bit to swap the order of presentations if our colleague Adriano must leave soon. So please, Adriano, you can start. The floor is yours.
Thank you, Jose. Does this work? Okay. Do I need a remote control for the presentation or? No. It was supposed to be a remote, no, for the slides? Yes.
Sí.
Sí.
Ya está bien.
Vale, gracias. Okay, thank you, Jose, for the introduction. And hi, everyone. It's a pleasure to be here presenting this very important topic for everybody as a society. I mean, for me, as a motorcycle rider, I take this topic very, very seriously, and it's an honor to take part of this mission. So what I am going to present today is not the ultimate solution to the problem. There are many solutions. There are many different ways, different avenues to tackle this problem. So what I am going to present today is which steps have we taken already at EuroNCAP and which steps are we going to take in the coming years to tackle, to reduce the motorcyclist accidents in Europe. And the Vision 2030 document is a document that you can find in our website. I invite you all to have a look at it. It summarizes our future plans, our plans for the coming 10 years to tackle safety in many different areas, from a passenger car safety point of view, commercial vehicle safety point of view with our truck program starting this year. PTW safety is also in our agenda. This is what I am going to present today. And also shared and autonomous mobility. This is a bit more for the future. I'm not going to enter into details of what has been presented already by other colleagues. This is the data that the European Commission put together for 2021. What is clear from this picture is that we really have a problem. The problem is still there and it's a really severe problem, right? Motorcyclist accidents represent a very big share of accidents in Europe, and it's very impressive to me to see that it's kind of half-half. The first half is crashes involving other collision partners, so car to motorcyclists, for example, and the rest of the accidents are just riders killing themselves alone on the road, right? So that's it's a very difficult problem, and I'm not sure if we will ever get to zero. I think it's very difficult to get to zero, but definitely we can do our best to reduce it as much as possible. Some observations that have been already pointed out by other colleagues yesterday. Motorcycles are affordable. They represent the concept of freedom. They give access to mobility to people that have low income. They have low carbon emission. So motorcycles are good, right? And I love motorcycles myself, and I really believe that with sufficient measures we can do a good thing from a safety point of view. So we need training, we need enforcement, we need infrastructure, we need vehicle safety from both the car and the motorcycle itself, and also protective equipment. So all these angles are part of the solution. The structure of this presentation and what we have in mind at EuroNCAP is a kind of a three-pillar approach. First of all is the ADAS, Advanced Driver Assistance Systems, that can prevent situations, safety-critical situations. So for example, when you lose focus on the road, when the unexpected happens, these are systems that are there to help you when you need them, right? Connectivity is a bit maybe a view towards the future. It is not yet clear, for me at least, how connectivity can help when we already have quite capable onboard systems. The current state of the art for ADAS is quite capable already, but nevertheless we don't close the door to see what connectivity can do to increase safety for cars and for motorcycles as well. And also ARAS, so Advanced Rider Assistance Systems. So for example, corner ABS is a system that definitely will add safety to the rider. So going into the detail on these measures, when it comes to ADAS, we took a significant step back from 2023. We incorporated car-to-motorcyclist scenarios in our program. So we are testing already vehicles, what is the capability of these vehicles to avoid or reduce mitigate the severity of accidents against motorcyclists from a car perspective through a wide variety of scenarios. So car-to-car rear stationary, car-to-car rear moving, turn across path, the crossing scenario will be introduced in a couple of years. So definitely systems that will be, for sure, adding safety and protecting motorcyclists. And the Muse project was where it all began, right? Back in 2017, and for 2 years, all these scenarios were being developed with the outcome that we have today in our protocols. Yeah, here you have a few schematics about how these protocols are looking like, all the different scenarios that we are taking into account for the test and assessment of the most sold vehicles across Europe. Every single vehicle we test will go across these scenarios. And these scenarios represent a big share in the points to have the 5 stars on safety. And then we also have the assisted driving program, which has been launched this year. So this is under the scope of level 2 systems. So the combination of adaptive cruise control and lane centering, and how are those systems taking into account motorcyclists. So we have even more critical situations like the car to motorcyclist got out, car to motorcyclist got in, and even some scenarios in which we have introduced robustness, right? So here the main collision partner is the motorcyclist, but we put another vehicle in front just in case the sensing will have an issue to recognize who is who. Right here as well we have another situation. So always trying to step up the requirements when it comes to collision avoidance. Up next, well, like I have said, we will have additional scenarios in 2026 for car to motorcyclist scenarios as a part of our 5-star rating program for cars. Vans will also have to fit these systems by standard to get the maximum rating in 2026. And for our truck program, trucks will also have to fit as a standard system that are avoiding accidents with motorcyclists from 2027. Connectivity, I'm not going to enter too much into detail here because Hennes will definitely give you a good overview of what connectivity can do for motorcyclist safety. Just telling that Secure project led by UTAC last year put together a few scenarios that could potentially add safety to motorcyclists, to motorcycle safety. And here we have a potential timeline of technology adoption for car-to-part PTW technology that can prevent accidents by means of vehicle-to-everything. A lot has been said already. This is the third pillar, Advanced Rider Assistance Systems, ARAS. So maybe you could argue, what is EuroNCAP doing here? EuroNCAP is about safer cars and not about safer bikes. But definitely we think that motorcycles are part of are a big part of the problem in Europe. And we think that at least it's good to give consumers an overview of what these technologies are about, which bikes are fitting these systems as standard, and how these systems can help you as a rider to prevent accidents in a wide variety of situations. There are technical challenges, for example, the big diversity of vehicles that we have in the fleet. Of course, the complexity of the integration, these systems are not the same when they are fitted in cars than in motorcycles. The PTW dynamics is a really complex issue. A bike is not the same as a car, again, not the same animal. These systems are mostly fitted in expensive motorbikes. It's not always the case, but as a rule of thumb, that is the current situation. And how riders are going to accept these systems, that's also a big question. So, well, just a very simple overview of what these advanced rider assistance systems can be about. So we have maybe a comfort system, adaptive cruise control, can be there for comfort, but it can also be there to help you when you need it and you lose focus. Speed limiter, just the normal speed limiter that you set at your own will, it definitely adds For me, as a rider, I value these systems a lot. eCall is something that I think adds an enormous value when you have an accident in the bike and you will have emergency services on the spot within 10 minutes or 15. I mean, every bike should be equipped with eCall for me, no doubt. I will pay the extra money for this system, no doubt. And then, of course, you have ABS, corner ABS with the most sophisticated version, blind spot monitoring, traction control, for collision warning. These systems are there to help you when you need them the most. Last but not least, I just want to provide an overview of what our future plans are. So we're going to start a new working group this year in EuroNCAP with all our members, in which we are going to try to tackle the issue of PTW safety. We will make a market, a safety campaign in which we will understand the ways to inform consumers about what the systems are, how do they provide value, and which bikes are having these systems as standard. And if not as standard, how much money you need to pay to get them in your bike. So this is it from my side. Thank you very much, and you can reach out to me if you have any questions.
Thank you, Adriano. Since Adriano has to take a plane in Barcelona in few hours, and just to allow time enough to drive to Barcelona, always fulfilling the speed limits, I'll just go through and ask you just one single question, and after that, please feel free to leave when you need it. Just about crash results in the EuroNCAP test, how have the vehicle assessed so far by EuroNCAP responded in the car-to-motorcycle crash avoidance test? It's a quite interesting question, and we are pleased to hear results.
Yeah. Hola. Yeah, so last year we assessed something like 25 cars. It was not a really busy year. This year we will assess something like 40 cars, and next year something like 70 cars. So next year is going to be really hectic for us. And all these cars will go across the car-to-motorcycle scenarios that we have, among many other scenarios. So far, I was looking at some data earlier this week about how cars have performed in this scenario so far. And generally, it's good. Generally, the cars that we have assessed so far have demonstrated to be effective at avoiding, not even mitigating, but avoiding the collision. There are a few exceptions. The most difficult accident scenario is the turn across path. So a situation in which you are making a left turn and there is a motorcyclist oncoming on the other lane. This is a difficult, from a sensing point of view, the crash avoidance system is having a challenge to detect the oncoming motorbike and avoiding the situation at the last moment. So some cars have been struggling with that particular situation, but definitely there is a big incentive in points to get the 5 stars. So we have seen that manufacturers have been really serious when it comes to adopting these technologies. And moving forwards, we will, like I said before, in 2026, we will incorporate a new scenario, which is the crossing scenario. And this will step even further the requirements for this kind of system. So long story short, so far so good, with a few exceptions. Yeah.
Thank you very much. Thank you very much, and please feel free to leave when you need it, and our recognition to EuroNCAP for the big effort doing during the last 10 or 20 years. So thank you very much.
Thanks, Jose.
So we continue with the next speaker, Mr. Fischer. Mr. Fischer comes from the Connected Motorcycle Consortium and will talk us about connected motorcycles. So please, the floor is yours.
Yeah, first of all, thank you to the organizer, and in particular to DGT, to give the industry the chance to talk about future technologies. Now, in CMC, our slogan is Together for Rider Safety. But wait a minute. It's more than a slogan. Just imagine, back in 2015, so almost 8 years ago, 3 companies, Honda, BMW, and Yamaha, were sitting around a table saying, let's put competition aside for a moment. What can we do to increase motorcycle safety? And one of the key technologies we were looking at that time was connectivity. And it became soon clear for every one of us that it does not make sense that every one of us produces a silo solution, because the bikes need to communicate to each other. They need to communicate to cars, to trucks, to the infrastructure. So what we need from an industry point of view is a solution that has common standards so that the bikes can talk to each other and everyone else. So Together for Rider Safety is not a slogan. That's what we are doing. Now, I will explain you in a few minutes what we've done in the last 8 years. We had several phases. And in the meantime, the consortium has grown. We have other manufacturers been joining. We have researchers in the consortium. We have suppliers and engineering providers in the consortium. And you may be surprised if you hear it later. We've done much more than looking at connectivity. But before I do so, let me just show you a brief video that explains how the consortium works today.
The Connected Motorcycle Consortium is a collaboration between manufacturers, suppliers, researchers and associations to make powered two-wheelers part of the future connected mobility. CMC is a non-profit organization established by key motorcycle makers with the unilateral goal to improve motorcycle rider safety and comfort. Motorcycles are often not seen or recognized by other vehicle drivers. The catchphrase, digital conspicuity, describes recognition of PTW by means of exchanging messages to make the other vehicle drivers aware of motorcycles in the vicinity. Based on in-depth accident research, CMC has defined most relevant scenarios, where motorcycle riders are overseen by other drivers. CMC has developed CITS applications and scrutinized advanced driver assistance systems in cars to mitigate such critical situations. Autonomous emergency braking, AEB, features as part of advanced driver assistance systems, have been in series production for about 10 years. These systems are based on state-of-the-art sensors and additional information like map data. AEB functions are capable to avoid or mitigate collisions through warnings and automatic brake interventions. Due to current legal regulations, every series-produced car is equipped with advanced driver assistance systems and AEB systems. Therefore, this technology has a major impact on improving motorcycle safety. CITS stands for Cooperative Intelligent Transport Systems. This technology enables information exchange and collaboration between vehicles, infrastructure, and other road users.
Oncoming motorcycle.
Through the use of wireless communication, vehicles and infrastructure can exchange information in real time. This means, for example, that dangerous situations can be recognized early on. Both systems actively support road safety between motorcycles and other road users.
So the video showed some of the demonstration we've done last year. We invited industry stakeholders and we showed these use cases. But let me go on. I was talking about 8 years. Now, 8 years is a long time, and you can ask, why do you need 8 years to develop or set standards for connectivity? We've concentrated on connectivity in the first phase from 2016 to 2020, where we looked at what are the most critical scenarios, and Adriano was just mentioning them as well. That's left turn, and that's the crossing. They produce most of the accidents in collisions. So we looked at that, we set the functional requirements for the system, and we actually published what we call basic system in 2020, which describes the motorcycle system in a basic way. A lot of that also was aligned with the car industry. We are active in the Car-to-Car Communication Consortium, where we talk to car manufacturers and where we point out the differences between cars and motorcycles in terms of connectivity. So that was the first phase. In the second phase, from 21 to 23, we actually did this live demo, but we also started to look at ADAS systems in cars. And you can see that over there, there's this funny looking motorcycle. That's actually the motorcycle target for cars to recognize. So we have taken this on board at CMC, looking at the systems, assessing how they work, what we can do from an industry point of view, motorcycle industry point of view, to improve the recognition of motorcycles in these ADAS systems. And furthermore, we have done more in-depth accident studies because we realized in the first phase that developing a system without deeply understanding how accidents happen will not be successful, will not serve the purpose. So for the first time ever, I think, we have looked at hundreds of accidents using the German GIDAS database and trying to understand during a certain accident scenario what happened at every second and at what point in time a connectivity or warning system would be able to avoid the accident. This was a lot of work, but we felt it's necessary to go into accidentology rather than only developing technical systems in order to tailor the motorcycle systems. And furthermore, we realized, the rider is part of a motorcycle. It's the upper half of the bike. And we looked at rider reaction. How do riders react on warnings? How do they perceive certain situations and so forth? So as I said in the beginning, it's much more than just developing a connectivity system. Now we are in the third phase. We do more basic research. We're intensively continuing looking at ADAS systems, and we are looking at more a global scale to make sure that the German data is comparable to other countries. We've done that already in Italy, France, and Spain. And we've seen that it's comparable. We've looked at US, and we are now looking at Japan data. You know this slide, and in view of the limited time, I would just go on. So motorcycle accidents have not gone down like car accidents, but we hope with means of connectivity we can improve that. The main factor for the motorcycle accidents is that the car driver doesn't see the motorcycle. And also Adriano mentioned that about 70% of the collision accidents are because the car driver doesn't see the motorcycle. So that's this situation. Sorry, mate, I didn't see you. To avoid that, if we have a warning in the car that tells the car driver where the motorcycle is and that there's a dangerous situation upcoming, we feel that we can reduce a lot of fatalities and we can mitigate a lot of accidents. This is a short glimpse on the accident analysis. It just repeats what I said. Crossing traffic, longitudinal traffic to a certain degree, but lane change and left turn are the main problems. The blue color shows the involvement of the car driver in the accident. You can see in crossing and particular left turn, the blue color is quite big. And that is the typical situation where the car driver doesn't see the motorcycle. I've also, in view of time, I won't go through the whole slide. I already said we look at ITS and ADAS at the same time. And what we found in our tests and studies is that ITS is ideal for early notification because the system will realize if a motorcycle is like 300 meters away, the system already gets a notice and can then show a warning if it comes to a point where an accident is likely. And then you can show a warning in the car. Of course, also in a motorcycle, if it's motorcycle to motorcycle. And the ADAS system will be very good if the driver doesn't react. And you've seen this in the video. You know, the bike comes, the car driver doesn't react, but the car can brake because of the ADAS systems in the car. These were the scenarios we have been looking at. I think no need to go through in details. They are self-explanatory. It's a typical crossing and, oh, I need to hurry up now. The typical crossing and left turn situation, but also we found lane change situations quite dangerous, particularly when a bike comes from the rear and the car wants to turn left and the car driver doesn't see the motorcycle coming on. Well, yeah, I'm already through. This is the current membership. So you see we have a couple of motorcycle companies there and so forth. So thank you for your attention. If you have any question, we can catch up later. I've brought along a prototype with all the electronic equipment. It's an experimental vehicle which we use for testing. And please bear in mind, if it comes into production, of course, we will not have a top case full of electronics. The system will be about this size. But this vehicle is to exchange components, to try new software and try out different components and see what works best. That's the reason for this. And again, if you have any question, happy to answer. Thank you.
Thank you very much. Thank you, Mr. Fischer. Next speaker, Mr. Brend, coming from Honda Motor Europe, will talk us about advanced rider assistance system. So, please, the floor is yours.
Waiting for the remote to work. Okay. Good morning, everyone. Buenos dias to everyone. My name is Brend Brauwer. I'm the chairman of the working group ARAS, so working very closely with our safety manager, Veneta, and with Antonio. I also work for Honda Motor Europe in the Regulatory Affairs Office. And today I got the wonderful opportunity to be here and to present our European motorcycle industry views on advanced rider assistance systems, thanks to DGT and Asesor, who organized this great event. So I know how much work went into this to bring this together, to bring everybody together. So thank you very much for this event, and I'm enjoying it so far, and I would recommend to continue enjoying it. It's been a great 1.5 days already. On Tuesday, I got a question from someone in the audience, what is ARAS? And at first, I wasn't sure what to think about this question, because sure, we're all industry experts here. But actually, it's a very good question, because it shows that not everyone is sufficiently aware about which technologies are being developed by the motorcycle manufacturers and which technologies are being deployed. So this is like the ideal introduction for my presentation, and that is also why, together with Asesor, we have done a lot of efforts, and with the national sales branches from the manufacturers, we've done a lot of efforts to bring all the bikes here. You can see them on the left and right side of me. So we've done a lot of efforts to bring the bikes here for you to have a look at these systems, to look at them, to have a look at them very up close. And in front of the bikes, there is also a description, so a description of the function with which the bikes are equipped, and we can see the range of power two-wheelers. We have the scooters, we have bigger commuter bikes, sports touring bikes, so representing also the variety of our products. So if you haven't done already so, I would really recommend you to have a look at the description for you to learn and to take something away from this. Before we go into a bit more detail of advanced rider assistance systems, I would like to put this in perspective in relation to our ASAM road safety paper. So Veneta already introduced our ASAM road safety paper, in which we outline all of the building blocks from the safe system approach. Veneta highlighted our ASAM efforts for the green box, so the safe road users. But of course, representing the manufacturers, safe vehicles is also very important and is an integral part of our ASAM safe system approach, protecting the rider through advanced technologies, but also continuous innovation, and especially cooperation also with other stakeholders. Hennes talked about the need to cooperate for connectivity systems, but also for other safety systems. We cooperate with other industry stakeholders such as ETSC, also with EuroNCAP, with the car industry through ASEA. And in addition to technology on our bikes, we of course also continue to advocate for the detection of powered two-wheelers by other road users. Adriano explained this as well, that it's very important that cars, vans and trucks are able to detect motorcycles through the application of ARAS technology on those vehicles. And then of course in the future we will have the cooperative ITS systems, which then hopefully will be able to give a warning very early on to the rider. And of course, on top of all, these systems need to work for the lifetime of the product, so we encourage continuous maintenance for these systems in order so they continue to be working as designed. If we have a look at the accidentology, and Hennes already mentioned it, if we have a look at the collision-based accidents, so these are the accidents in which another vehicle is involved, we see that 80% of those crashes, the opponent vehicle is a passenger car, and in 60% of those cases, it was the driver of the car that didn't see the bike coming. So that's why, again, it's very important that we also continue to advocate for sufficient detection of powered two-wheelers by other vehicles on the road, because a large portion of these accidents come from these collision-based accidents. Then the other accidents are the rider-based accidents, so these are single-case accidents where we see that the main cause is the loss of control over the motorcycle. And this then also brings me to the other part, so the influence of the rider. If we want to reduce the risk of riding error and risk, the most important is to address the rider, because the rider skill is so crucial and is still number one priority for us to improve their behavior and to reduce the risk of riding error. In addition to skills, so being able to see the traffic, control the bike, also mindset and behavior is very important. We see that high-risk riders in traffic that look for the limits of riding dynamics and go beyond the limits of technologies that are deployed on our bikes, this audience is not susceptible for any awareness campaign, and it's very difficult to reach those people. On the other hand, we have, of course, the safety-oriented riders. These are the riders that we need to continuously train over their lifetime in order for them to have sufficient skills, which is really important to reduce the riding risk. But very importantly, also with the introduction of these many new technologies, and Adriano already mentioned this, we still see that many riders are not sufficiently aware about how they work, what they are designed for, what do they do, but especially also the limitations of these systems. So these systems are designed in a certain way, but they also have specific limitations. And it's very important that the rider, our users, they understand these limitations and correctly use the systems. They do not switch them off, otherwise the systems, as we have designed them, cannot perform very well. If we have a look at the development of advanced powered two-wheeler systems over the years, we see that we are in the beginning focusing, and this is the yellow parts of the bottom parts, the first kind of systems were the reactive systems that were developed and introduced on the market. So these are systems that react, for example, ABS, if you exceed a certain braking limit, or traction control if there's some external factor where the traction is lost. So these are reactive systems. We saw the introduction of ABS in the late 80s, then followed by rear-wheel lift-off prevention and cornering ABS in the late 90s. Then traction control came, emergency stop signal around 2010, and then with the introduction of cornering ABS mid-2010. So this is just a non-exhaustive list to show also the evolution. But and in the most recent years, we now switch from reactive systems So all of the bikes on the left side basically have these systems. We switch also to the perceptive systems, of which the bikes on the right side are equipped with. And these are systems, as the word says, that perceive, look at the environment in front of the bike and in the back of the bike in order to give a warning to the rider. I just want to highlight two technologies. First one is blind spot detection. So this works in a lane change scenario where the system based on radar at the back is able to alert the rider whether there's a vehicle in the blind spot of the bike. And the aim is to enhance the awareness of the rider and promote safer lane changes. The other system, which is at the moment the most complex system that is mass-produced and is equipped on bikes, is the forward collision warning system. And these are systems that look at the environment in front of the bike and can then alert the rider in the event of a potential collision with a warning. But very important to mention is that the bike or the system is able to give a warning to the rider very close, but is not able to take over the control over the motorbike. So that's a very important difference that we see with car systems, where we are able to brake for 100%. With a motorbike, this is not possible. Otherwise, we risk the dynamics and the stability of the bike. So it's only as good at the end as the rider that still needs to make the correct assessment and still needs to either brake or avoid the situation. This is a very important difference between systems on cars compared to the systems on the motorbikes, which may have a similar name. So in conclusion, our industry safety vision promotes an integrated approach. Vinita already mentioned this. Technology is one part of the solution, but we need to also look at sufficient rider training to create a holistic safety ecosystem. The manufacturers are deploying advanced power two-wheeler systems on the bikes. You can see them here, considering their specific use on the road. So not all the bikes are the same, and also considering their specific characteristics for riding. We also continue to stress again the importance of rider training, because these systems cannot make the rider a better rider. They can get some awareness, so that's continuously, it's very important that we highlight the rider training and correct use of these systems. We also, when it comes to accidentology, would recommend the member states to implement a standardized data collection and make this data available across the member states. So for us, it's easier to perform real-world effectiveness analysis of these systems, because we have some data from some markets, but this across Europe, there is still a lot of efforts to do to bring the data together. And of course, also for these systems, we are committed to a collaborative approach with other road safety advocacy stakeholders to raise awareness about these systems, to raise awareness for the safe vehicle technology. So we are already working with EuroNCAP, with ETSC, ASEA, and VIAS. So thank you very much for having me, and I'm open for any questions afterwards.
So thank you to the speakers, and thank you to all of you. Unfortunately, due to timing constraint, we have no time to question. So please feel free during the breaks to, if you have any question, any concern, please no complaints, only suggestion and comments. Please contact us in any moment. Thank you very much.